Hello IT pros, welcome to my IT workshop, and this is going to be the first video for IPv4 subnetting, but first we have to understand how binary works. So without further ado, let's begin explaining how this works. Okay, in binary, as you can imagine from the name, we only use two digits or two numbers, zeros and ones, or 0 and 1. In contrast, decimal, we use 10 digits, as you know, from 0 to 9. With these numbers, we can create any amount that we know. So what do we use binary for? Well, binary helps us to represent two values, on, which is number 1, or off, which is number 0. But they also can represent the value of true or the value of false. Okay, ones and zeros are the way computers communicate one to another. So as you might imagine, computers don't talk to each other like we do with words. They only understand numbers, and these numbers are in binary, so they only understand ones and zeros. That's all they do. All computers understand are ones and zeros. Dealing with binary. Okay, just to start off with binary, we're going to need to know how to add, how to subtract, how to use exponentials. Subtract, perhaps not that much. I'm going to start defining a bit, which is the smallest unit of data. A bit can be 0 or 1, true or false, or on or off, positive or negative, as we can see before. One step up, we can find a byte. A byte is formed by 8 bits. Okay, we're going to talk about bytes later. Now, we're going to use some boxes. These boxes are the numbers we're going to use to represent most of the number we're going to need. Starting from left to right is from 1 to 128. As you can see, every number to the right is the double of the number on the left. But don't panic, I know it sounds like, so these numbers are random or what? I'm going to explain how we came up with those in a few minutes. So these numbers, like I said, are the only ones we're going to need to learn IP addressing. So how about now that we understand a little, if we do some examples? What if I want to represent the number 147 in binary? The first step is we're going to use the boxes, okay? And any number I need to create the number 147, I'm going to put a 1 under it. If I don't need the digit or the number in decimal, I'm going to put a 0 under each box. So do you think I'm going to need 128 to form 147? Yes, because 128 is less than 47, so I need it. I put a 1. What about 64? 128 plus 64 is 192. A little too high, so I don't need 64. What about 32? Well, let's see. 128 plus 32 is going to be 160. It's still too high, so I don't need 32. Let's try with the next one, 16. 128 plus 16 is going to be 144. Yes, I need 16. It's closer. It's less than 147. You can tell that I'm only missing 3 numbers, so I don't really need 8. I don't really need 4. But I'm going to need 2, because 144 plus 2 is equal to 146. And lastly, number 1. So I type number 1 under 2. So 146 plus 1 is going to be 147. So we have achieved our goal. So these numbers in binary are the result of 147. So 147 in binary is going to be equal to 100, 100, 11. We have to write down the zeros as well, not only the ones. All right, let's try another example. This is going to be a smaller one. What about if you want to represent 34 in binary? You guessed it. I'm going to call the boxes one more time, and we're going to start working on it. Do you think I'm going to need 128 to represent 34? 128 is way too high. I don't need 128 to represent 34. So I'm going to type a 0 under it. What about 64? I don't need it either. 32? Yes, because it's less than 30, 34. What about 16? I don't need it. I just need two more numbers. What about 4? No. What about 2? Yes, I need 2 to form 34. What about 1? I don't really need the 1. So 34 in binary is going to be 0, 0, 1, 0, 0, 0, 1, 0. It's getting better, right? What about 128 in binary? Can you tell me? Really quick? Okay, let's do it then. So 128 in binary is going to be equal to 1 followed by 7 zeros, because I only need the first box starting from the left. That's all I need. The rest is useless for this number. Let's try a smaller number, 3. Can you tell me? Okay, let's try what we get. So do you think I'm going to do 128, 64, 32, 16, 0, 8 and 4? No, it's going to be 6 zeros followed by 2 ones. So number 3 is equal to that amount. We're going to try one more, 255 in binary. This number is a little big, so if you stop the video, you can do it yourself. But 255 in binary is going to be 8 number ones, because if you add 128, 64, 32, 16, 8, 4, 2, and 1, it's going to give us 255. So this is the largest number we can form with these 8 boxes or decimal digits. Now, what if, this is just for you to understand, what if I want to represent 305 or 305 in binary? So you guessed it, we are going to still use the boxes. But didn't you tell me that we can only represent 255? 305 is way bigger. Yes, but we can add the next double of the last number. In this case, the double of 128 is 256, right? So we are going to do the same process. Do I need 256 to represent 305? Well, yes, I need it. What about 128? Would be way too big. I don't need it. 64, I don't know. Let's try. 256 plus 64 is going to be 320. I don't need it. It's way too big. What about 32? Well, 256 plus 32 is going to be 288. I need this number because it's smaller. What about 16? 288 this time plus 16 is going to be 304. Yes, I need 16. By this time now, you can tell that I don't need 8, I don't need 4, and I don't need 2. The last number I'm going to need is 1, which is, well, I'm going to write number 1 under it. So 305 in decimal is going to be 100110001 in binary. So this is how you do. You can represent any number you want in binary. Doesn't matter how big it can become. But for IP addressing, we only need 8 boxes until 128. Okay. But what if we need to do it the other way around? What if we have the binary number and we need it in decimal? So what are we going to do? This is new. In order to do this, we're going to still use the boxes, but we're going to do something else. First, I'm going to explain where these numbers came from. They are not just random. Computers don't understand how we add numbers the way we do. They use exponentials, very basic. So 1 is equal to 2 to the power of 0. 2 to the power of 1 is equal to 2. 2 to the power of 2 is 4. To the power of 3 is 8. To the power of 4 is 16. To the power of 5, 32. To the power of 6, 64. And finally, 2 to the power of 7 is 128. Why do we use 2? Because it's binary. We only have 2 numbers. That's the reason. Okay, so we are going to proceed with the exercise. The first thing we're going to do after we have understood this is we are going to copy the numbers we want to convert. So we have 0, 1, 0, 0, 0, 1, 0, 1. And now I'm going to call the boxes under it. And I'm going to match each digit in binary to one of the boxes in decimal. So we have 8 up and 8 down. So you can guess, wherever I have a 0, I don't need a number. Whenever I have a 1, I'm going to need that number. So let's continue. Do I need a 28, 128? No, there is a 0 on it. I need 1, I need 64. Yes, I need it. 32, I don't need it. 16, I don't need it. There is a 0. 8, same case. And the next numbers, 4, yes, I need it. So number 2, I don't. And number 1, I need it too. So if I add these numbers up, I'm going to have 64 plus 4 plus 1, which is going to be 69. So in other words, 0, 1, 0, 0, 0, 1, 0, 1 in decimal is equal to 69. It's looking pretty good, right? Okay. Let's go to the next exercise. This is going to be a little smaller. What about 1001 in decimal? But we only have 4 numbers. We are used to 8. So how is this going to work? Well, the way this is going to work is that we need to complete this binary number with zeros to the left. This is very important, guys. To the left, not to the right. So I'm going to type the number 1001 and I have 4. I need to complete it to 8, but in order to do that, I need to add the 4 zeros to the left, not to the right. So I'm going to write 4 zeros. Okay, so I have 8 digits now. I'm going to draw the boxes again, and I'm going to do the exact same process. Do I need 128? Not really. I don't need 64 either. I don't need 32. I don't need 16. And when you have more practice with it, you won't need to do this. It's going to be really, really quick. Again, I don't need 16. I do not need 4, and I don't need 2. The only 2 digits I need in decimal are 8 and 1. So if I add 8 and 1, I'm going to have 9. So in other words, 1001 is equal to 9, or 1001 is going to be equal to 9. Well, with these examples, I hope you have a better understanding of how the process of converting from binary to decimal, from decimal to binary works. And I encourage you to do a few more, let's say 2 of each. For instance, you can convert 150 to binary and 100101110 to decimal. So you will have an even better understanding of how the numbers work. So that would be for the video, guys. I really appreciate that you watched this video. If you like it, please leave a like and consider subscribing to the channel, and I'll see you in the next one.